Large language models cannot self-correct reasoning yet. Large language models, LLMs, have emerged as a groundbreaking technology with their unparalleled text generation capabilities across various applications. Nevertheless, concerns persist regarding the accuracy and appropriateness of their generated content. A contemporary methodology, self-correction, has been proposed as a remedy to these issues. Building upon this premise, this paper critically examines the role and efficacy of self-correction within LLMs, shedding light on its true potential and limitations. Central to our investigation is the notion of intrinsic self-correction, whereby an LLM attempts to correct its initial responses based solely on its inherent capabilities, without the crutch of external feedback. In the context of reasoning, our research indicates that LLMs struggle to self-correct their responses without external feedback, and at times their performance might even degrade post-self-correction. Drawing from these insights, we offer suggestions for future research and practical applications in this field. ImagenHub, standardizing the evaluation of conditional image generation models. Recently, a myriad of conditional image generation and editing models have been developed to serve different downstream tasks, including text-to-image generation, text-guided image editing, subject-driven image generation, control-guided image generation, etc. However, we observe huge inconsistencies in experimental conditions. Datasets, inference, and evaluation metrics render fair comparisons difficult. This paper proposes ImagenHub, which is a one-stop library to standardize the inference and evaluation of all the conditional image generation models. Firstly, we define 7 prominent tasks and curate high-quality evaluation datasets for them. Secondly, we built a unified inference pipeline to ensure fair comparison. Thirdly, we designed 2 human evaluation scores, that is, semantic consistency and perceptual quality, along with comprehensive guidelines to evaluate generated images. We train expert raters to evaluate the model outputs based on the proposed metrics. Our human evaluation achieves a high inter-worker agreement of Krippendorff's alpha on 76% models with a value higher than 0.4. We comprehensively evaluated a total of around 30 models and observed 3 key takeaways. 1. The existing model's performance is generally unsatisfying except for text-guided image generation and subject-driven image generation, with 74% models achieving an overall score lower than 0.5. 2. We examined the claims from published papers and found 83% of them hold with a few exceptions. 3. None of the existing automatic metrics has a Spearman's correlation higher than 0.2, except subject-driven image generation. Moving forward, we will continue our efforts to evaluate newly published models and update our leaderboard to keep track of the progress in conditional image generation. SmartPlay, a benchmark for LLMs as intelligent agents. Recent large language models, LLMs, have demonstrated great potential toward intelligent agents and next-gen automation, but there currently lacks a systematic benchmark for evaluating LLMs' abilities as agents. We introduce SmartPlay, both a challenging benchmark and a methodology for evaluating LLMs as agents. SmartPlay consists of 6 different games, including Rock, Paper, Scissors, Tower of Hanoi, and Minecraft. Each game features a unique setting, providing up to 20 evaluation settings and infinite environment variations. Each game in SmartPlay uniquely challenges a subset of 9 important capabilities of an intelligent LLM agent, including reasoning with object dependencies, planning ahead, spatial reasoning, learning from history, and understanding randomness. The distinction between the set of capabilities each game tests allows us to analyze each capability separately. SmartPlay serves not only as a rigorous testing ground for evaluating the overall performance of LLM agents, but also as a roadmap for identifying gaps in current methodologies. We release our benchmark at the project's website. Large language models as analogical reasoners. Chain of thought (COT) prompting for language models demonstrates impressive performance across reasoning tasks, but typically needs labeled exemplars of the reasoning process. In this work, we introduce a new prompting approach, analogical prompting, designed to automatically guide the reasoning process of large language models. Inspired by analogical reasoning, a cognitive process in which humans draw from relevant past experiences to tackle new problems, our approach prompts language models to self-generate relevant exemplars or knowledge in the context before proceeding to solve the given problem. This method presents several advantages. It obviates the need for labeling or retrieving exemplars, offering generality and convenience. It can also tailor the generated exemplars and knowledge to each problem, offering adaptability. Experimental results show that our approach outperforms zero-shot CoT and manual few-shot CoT in a variety of reasoning tasks, including math problem solving in GSM 8K and math, code generation in Codeforces, and other reasoning tasks in Big Bench.